The last type of reactions we will learn in this chapter are redox reactions. What is a redox reaction? It's a reaction in which electrons are transferred. So we can also call it an electron transfer reaction. So one of the element in the reaction is going to lose electron, and another element in the reaction is going to gain electrons. And these sort of reactions are called redox reactions. We can also call them reduction oxidation reactions. So basically, this is the short form, and this is the expanded version. Redox means reduction oxidation. So in a redox reaction, you always have one substance transferring its electron to the other. One substance is losing electron and the other gaining electron. And we use some terminology here. The substance that has lost an electron, we say it is oxidized. Okay, or we can also say this substance is undergoing oxidation. And reduction, on the other hand, is gaining of electrons. So this substance that has gained an electron is said to be reduced. Okay, here's a little mnemonic that will help you to remember this. Leo the lion says grr. So loss of electrons is oxidation, and gain of electrons is reduction. Now you may be wondering, why is gain called reduction? Doesn't reduction always mean losing? How come reduction is gaining of electrons? So here's the reason, because when we say an element is reduced, its charge is reduced. Okay, and how does charge get reduced? How does an element's charge go down? Suppose you started off with Cu3 plus. How do you reduce the charge? Well, you have to add electrons. So you have 3 plus charge. If you add one electron, you get Cu2 plus. If you add one more electron, you get Cu plus. You add one more electron, you get neutral copper. So as you add electrons, the charge reduces. So that's why we call it reduction. Okay. So you need to remember this term, and this term will help you figure out which one is reduction. Okay. That's gain of electrons. All right. Now, what are some of the redox reactions from your daily life? Well, rusting of iron. That's a classic example of a redox reaction. So think about what is rusting. So basically, iron converts to iron oxide. So if you look at iron, it's neutral iron. Um, Iron metal is just Fe. The charge is 0. And rust is iron 3 oxide. This is the formula for rust. The common name is rust. The chemical name is iron 3 oxide. Iron 3 oxide. Okay. Within this compound, iron has a charge of 3 plus. So what has happened to iron during this reaction? Well, iron should have lost electrons. Okay. That means it is oxidized. Iron has lost electrons, meaning it is oxidized. Now, what element in this reaction has gained electrons? Well, if you look at oxygen, oxygen started out neutral. And then on the product side, in the rust, this is an oxide ion, okay? Here we have an ionic compound with ions charge 3 plus, and oxygen's charge is O2 negative because it's an oxide. So since oxygen has gained electrons, we can say oxygen is reduced in this reaction. Okay. Most of the ores, for example, bauxite. Bauxite is an ore of aluminum. It's basically aluminum oxide ore. Okay. It's hydrated aluminum oxide. So what do you need to do to convert to get aluminum from bauxite? Okay, most of the ores are oxides of that metal. Okay, for example, iron ore is basically has most of iron oxide. So how do you get the metal from their ores? Think about it. Do you have to reduce or do you have to oxidize? Here we have ions. So aluminum here is an aluminum ion. Iron here is in the form of an ion. So these have positive charges, and we're trying to get to neutral metals. So you have to add electrons. Okay, the ions have to gain electrons to become just neutral metals. That means we have to reduce them. So in metallurgy, when you get metals out of their ores, basically what you're doing is you're reducing the ore to give you the metal. Well, what about Statue of Liberty? Where is the oxidation reduction here? Well, Statue of Liberty is made out of copper, and you know that's the color of copper. That's what it should have looked. But over time, what has happened is the copper there got oxidized and it has converted, it has reacted with carbon dioxide and moisture and sulfur dioxide in the air, and it has eventually converted to lots of different copper compounds. And within these compounds, copper has either 2+ or 3+ charges. Okay, so what has happened to copper is it has gone from 0 charge to compounds within which copper has positive charge. That means copper should have lost electrons. So over time, copper has oxidized, and basically lots of copper oxides containing 2+ or 3+ ions, they're blue in color. So the blue patina that you're seeing on Statue of Liberty is due to oxidation of copper to copper 2+ or copper 3+ compounds, which are blue or bluish green in color. Okay, here's another terminology. The substance that is oxidized is called reducing agent. Why? Agent means helper, right? So if you hire a detective or an agent, it's helping you get some result, okay? So reducing agent is the substance which helps other substances get reduced, okay? So it has to, for example, here, um, you can see iron is oxidized. Okay, by itself getting oxidized, we said earlier, oxidation means loss of electrons. So it is giving electrons to oxygen and helping it get reduced. Okay, since iron is helping oxygen get reduced, we say iron is reducing agent. So what's happening to iron? It's itself is getting oxidized. Okay, so be familiar with this terminology. The substance that is oxidized is called reducing agent. The substance that is reduced is called the oxidizing agent. How do we determine whether a substance is oxidized or reduced in a reaction? You have to write down the oxidation state of each element in the reaction. And I have uploaded a video which came before this video on how to assign oxidation states to some elements. Okay, for example, hydrogen has a rule, oxygen has a rule, fluorine has a rule. And the ones that don't have a rule, you determine them based on the fact that the sum of oxidation numbers in a molecule should be equal to its charge. Okay, um, so let's use these rules and do some problems. Here's the first one. What is the oxidation state of chromium in this ion, in this substance? Okay, so from the rules, we can assign oxidation state for oxygen. So oxygen has a rule. So oxygen is usually -2 unless it's an oxygen within a peroxide or a superoxide. Okay, peroxide ion is basically O2, 2 negative. This is the peroxide ion. So for example, H2O2 will be a peroxide. Okay. For example, potassium peroxide, potassium ion is K plus because potassium is in the first group, and peroxide ion is O2, 2 negative. And when you do crisscross, K2O2. Okay, that's a superoxide. That's potassium superoxide. Sorry, potassium peroxide. That's potassium peroxide. Okay, and this is a polyatomic ion here. So this ion here is O2, is a polyatomic ion, and you don't reduce it because we have an ion here. You have two potassiums for every one peroxide ion. Okay, so except in peroxides and superoxides, you can look up what a superoxide is. Basically, it's O2 negative. This is superoxide ion. So except in superoxides and peroxides, oxygen is always assigned -2. Okay. Now what should be chromium's oxidation state? Let's assign it X and then calculate it. So the total oxidation state should be, you have two chromiums, each having an oxidation state of X. So the total should be 2X. Okay. So we are going to next add the oxidation state of oxygen. You have 7 oxygens. Each has an oxidation state of -2. So that's a total of -14. The sum of the oxidation states according to the rule should be equal to whatever the charge is. The charge of this ion is 2 negative. So these two terms should add up to -2. Okay, so you can do some algebra. So X turns out to be +6. Okay, as you can see, +6 times 2 is +12. +12 minus 14 is -2. So the oxidation state of chromium is +6. So each chromium in this compound has a +6 oxidation state. Here's the next question, and I just put it on a different slide, question number 2. So we are asked, in the following reaction, which element is oxidized, which element is reduced? What is the oxidizing agent and what is the reducing agent? Okay, so we are given a reaction here, and to find out which element is oxidized and reduced, we're going to assign each element an oxidation state. And then we're going to look at, okay, from the left side of the reaction to the right-hand side, that means from reactants to products, which element gained electrons and which element has lost electrons. That's what we are going to do. Okay, so what would be the oxidation state of copper? The rule says if an element is, if you have an elemental element, the oxidation state of it will be 0. Okay, suppose you have O2. The oxidation state of oxygen in this compound will be 0. Suppose you have ozone, which is O3. The oxidation state of oxygen in this is going to be 0. Suppose you have silver. The oxidation state of silver is 0. But if you have silver plus, the oxidation state is +1. The rule says if you have an ion, then the oxidation state is going to be the charge of the ion. Suppose you have copper 2 plus, the oxidation state of copper is 2 plus in this ion. Okay, next moving on to the right hand side, what would be the copper oxidation state of copper in this compound? Well, you have 2 nitrates. In each nitrate is 1 negative. So what should be the charge of copper in this substance? It should be 2 plus because you have to balance the positives and the negatives, right? So if it's an ionic compound, figure out the charge of the metal, and the charge will be the same as oxidation state, okay? So the oxidation state here is going to be same as the charge of copper in this compound, okay? So we have seen that copper's oxidation state is changing from the left side of the reaction to the right hand side. So let's figure out what happened to copper. So copper should have lost electrons. It started out as 0. So if it loses electrons, it becomes 2 plus. So copper lost electrons. We can also say copper's oxidation state has increased. So oxidation state has increased. Okay. This means copper got oxidized. Okay. So we can say copper is oxidized. We said earlier that loss of electrons basically means oxidation. Okay. Instead of thinking in terms of loss of electrons, you can also think in terms of an increase in oxidation state. Increase in oxidation state means that substance is oxidized. So we have copper oxidized in this reaction, and any element that is oxidized will be the reducing agent. So you can say copper is, I'm just writing Ra for reducing agent. Copper is the reducing agent. Okay. All right. Now let's figure out which element has undergone reduction. Okay. So let's start with nitric acid and start assigning the oxidation states. According to the rule, hydrogen gets +1. Okay. Remember, hydrogen usual rule is +1. Assign it +1 unless it is an element. Suppose it's H2, then it gets 0. Okay. And unless it is attached directly to a metal, suppose hydrogen is attached directly to a metal. Here it's going to get -1 because sodium is in the first group. It's going to get +1 oxidation state. So hydrogen should have been -1 so that they add up to 0. Okay. So except when hydrogen is directly attached to a metal, um, the usual rule is assigning it +1. So we're going to assign +1 to hydrogen. Now, what about oxygen? Oxygen gets -2 according to the rule. Oxygen always gets -2. Sorry, there are exceptions. Oxygen usually gets -2, except in peroxides and superoxides. Suppose you have, this one is hydrogen peroxide. This is hydrogen peroxide. So if you have peroxides, within peroxides, oxidation state of oxygen is -1. Okay. Remember this ion, O2, 2 negative, is called peroxide ion. Okay. So within this compound, we have a peroxide, O2, 2 negative. And the oxidation state of each oxygen in that compound is -1. Okay. This is an exception, but otherwise, we assign it -2. The oxygen gets -2. So what will be the oxidation state of nitrogen? So let's assign nitrogen X. Okay, we're going to assign nitrogen X. So let's add up the oxidation states. So hydrogen, 1. Nitrogen, there's only 1 nitrogen, so X. So the total oxidation state for oxygen, 3 times -2, that's -6. And the sum of all oxidation states should be equal to 0 because this is a neutral compound. This compound is neutral. Okay, so sum should be equal to 0. That means X will be +5. Okay, so nitrogen has an oxidation state of +5 in nitric acid. Let's figure out what is the oxidation state of nitrogen. Oxidation state of nitrogen is in NO2. Okay, so oxygen gets -2 according to the rule. Let's assign nitrogen X. Okay, so the sum X plus 2 times -2, that's -4, should be equal to 0 again here. Okay, so that means the X here is equal to +4. It's +4. Okay, so nitrogen's oxidation state has gone from +5 to +4. Okay, +5 to +4. So that means we can say nitrogen gained electrons, or nitrogen's oxidation state has decreased. That means we can say nitrogen is reduced, which makes nitrogen the oxidizing agent. Nitrogen is oxidizing agent. Okay, so there's our answer. So which element is oxidized? The answer is copper. Which element is reduced? The answer is nitrogen. So which element is the oxidizing agent? The one that is reduced. So the answer here is nitrogen. Which element is the reducing agent? the one that is oxidized, so it will be copper. Okay. One thing I want to point out, we didn't really use these coefficients, okay, because the coefficients are going to factor out. It's going to be, if you do 4 times this, okay, that's still going to be equal to 0. So the 4 doesn't matter there. You can, the 4 can cancel out. So the coefficients don't matter when you're determining the oxidation states.